everybody, Lane here from Maker's Lane. My property is very windy. Doesn't matter what time of year, it is always windy. How my property's laid out is it's in the middle of a valley. So it's got farm field on one side and the other. So what that means is all the wind comes through here. So I'm gonna build a windmill. Never tried this before, probably gonna make a lot of mistakes. Well, let's get to it. I'm gonna try to just build it out of stuff that I have laying around my shop. We'll see. I might have to order a couple things. Let's see if we can generate wind. First thing I'm gonna do is build the props and then some way to mount it to a post. But let's get the props together and stand, and let's see if we can get some wind power and get the props to turn first. Because if we can't get rotation from wind, basically this whole thing's a scrap. These are the items I think I'm going to use to try and build the windmill part of it. So this will be the platform where I mount everything to. This will go underneath here, and this will be, it's the rotating part underneath the swivel chair. I took it off an old chair that I threw away, so that's going to go underneath here. This will be the rod. These are the bearings. These go on the shaft here. And then I already have these boards that I pre-cut, and they will go out here to hold the shaft. So these are actually, if you ever do moving boxes, they're for hanging clothes up on the big tall boxes. So I'm gonna cut a groove out of this, weld these together, and then weld this to the end of that. And then because they're a little bit flimsy, I'm gonna put a little bit of a bend in it. That's everything I need to get started, so I'll start by getting this put together. Alright, so I got this all welded up. Wasn't that complicated, just cut a groove out of there. And then I put a hole in here. I think I'm going to weld a bolt to the end of there. That way I can screw everything together. Now I just got to put a bend in these. Nothing crazy. A little bit like that. Okay, next thing I need to do is I'm going to cut this in half and then use this as the propellers to mount to that. And then I got to drill a hole in the center of it, and then I marked how far I need to drill these two. So that was easy. I also went ahead and cut this so that these can sit on top of each other. Alright, the next thing I'm going to do is weld this bolt to the end of that. Alright, so everything works on this. I added some stops on it. All these are is hose clamps. I just tightened them on here so that way the shaft can't move in and out. This is about where I want it. So the next thing I need to do is put a wing on it to catch the air, so this is always facing the way the wind is blowing. So what I'm going to use for that is I have this dishwasher I took apart, and I'm going to cut this out and put it up here so that this catches the wind. So, alright. Alright, so now that I got the props on and the wing catcher on the back here, I'm going to take it outside before I add the motor onto it to see if it actually catches wind. So that's what I'm going to do next. Well, it catches wind. Alright, well, I'd call that a success. There's really not that much wind right now, and I would say it works. As far as the wind catcher on the back, really not sure. We'll have to wait for a windy day where the wind changes a bunch to see if it actually works. So the next thing we got to figure out is how we're going to mount the motor to it. So now that we know that the turbine outside turns and all the mechanisms work, the next thing we need to look at is a motor to actually generate the power. There are two different types of motors you can use. You can use either AC or DC motors. So you have your AC motor, your DC motor, and then also you're going to need a battery. This is not what I'm going to actually use, I'm just using it to test it. And then some sort of controller. This guy's main purpose is to take the power from this, then divert it into the battery. And you don't want to overcharge the battery, because if you keep just pumping power into it, you're going to ruin the battery. So this is what you actually use to charge this, and then once this is fully charged, it allows you to put a load on it of some sort. So I think first I'm just going to put some lights or something outside, just something small. I have a big battery on order, it should be here any day now. So this power controller, it is for the DC motor. So as you can see, I already have this in a block mounted up, so this is ready to go. So I'm going to start off with the DC motor. I'm going to take the windmill down, bring it back in here, mount this to it, and then we're going to figure out how we're going to route the wires, because obviously that it has to be able to turn freely, which means you don't want the wires to get all twisted up, so you have to figure out a way to get the power to a stationary position from a rotating position. I'm going to 3D print a gear socket for this. So there's going to be a big gear on the wind turbine, and then there's going to be a small gear on here, so that way the wind turbine is going to turn pretty slowly, and then this will turn extremely fast, so that way we can generate as much power as possible. So the next thing we're going to do is we're going to 3D print something for this, then we will mount it, and then we will get all the wiring situated, and then we'll put it back out onto the post. So let's go to the 3D printer. Here's the gear all finished. The big one, the little one. So this will mount to here. So I got to actually get it mounted in place. And then this will be mounted to the shaft that will rotate. So now let's get the windmill back in here. Get this mounted to here and this mounted to the shaft. And then we'll worry about the wiring. right, so now I got it hooked up to my power controller. So this is as you can see, a solar charge controller. I'm pretty sure it'll work, but I'm not an expert at this, so I'm just gonna try it out. If it doesn't work, then, you know, I got it on Amazon, so I can just return it. You can see it comes off of here and just goes into here. Right here's your input, and then it goes to your battery, and then here's the load you have on it. I also got this battery. It's a 12-volt battery. The only thing that's special about it, the fact that it's a deep cycle, which means you can fully drain these and then recharge them, and it's not going to hurt the cells. But yeah, so that's the only thing special about this. This is like a $90 battery, so this is the most expensive thing I bought. Everything I researched though says you got to have one of these, or you're just going to burn through batteries. You can see on here that it works, so you have to get it at about a specific speed. So you can see once it starts turning fast enough, it starts saying it's charging. I'm gonna try and get this all in picture. So I got my multimeter here. It's up to 20 volts. And I just want to show you, I got it just basically hooked up to this. It's not actually hooked up to the controller here or the battery or anything. So I just barely move this and you can see the voltage starts to go up. So that tells me that I'm at least getting power out of that motor. Once it hits about that fast, it starts to do it on its own. So my next step, I'm actually going to go take the base that this is going to mount to underneath. And I got some of this copper tape. And what I'm gonna do is so that this bottom piece can freely rotate, I'm going to make a circle, actually make 2 circles around it. And then I will hook up wires on the bottom of here that sit out, and they'll have a spring on them so that they're forced down. But then as this whole thing rotates back and forth, it'll stay in connection with the plate, and then the battery will be sitting underneath. I still got to encase all this thing, so I got to figure out how I'm going to encase it, because I got to make it so it's waterproof. What I'm going to do next is go grab the plate off the post out there, and then get this tape mounted to it and get all that set up. All right, so I went ahead and took the plate off the post outside. I drilled a hole in it, 3/8 hole, and I got a 3/8 dowel rod in it. And then I have this plate I made out of some pegboard I had just lying around. All I'm gonna do is put that on there. And then I have these 2 holes in there are the 2 different areas I want to put the channel. I'm gonna start with this hole. I may have to adjust it once I get started to see where I want it to actually end up. So then I take my router, which has just a flat bit on it, and I put it in the hole. There we go. We got the channels in there. The main thing was just to keep these 2 separated. That way they have a channel to run in. I probably really didn't need to do this. I probably could just left it on there, but this also keeps, if I have the 2 prongs in here, it keeps them from moving side to side and catching on the other one. So now that this is done, I'm gonna go ahead and put the tape in there. So here's the bottom plate that I'm gonna have to mount this to. So I need to know the distance from the center to these points. And if I put it at about 3.5 inches away from the center point, we should have the mounting holes for this. And that way I can pre-drill these holes in here, and I don't have to worry about it getting in the way. And then I'll have a good idea of where I need to put the tongs to come out to make contact with this copper piece. So let's drill the holes, and then we'll come through the base plate here with the power lines and make a tong out of something. Haven't really figured out what yet, but I'm sure I have something laying around that will make a good tong. Yeah, I think I figured out what I'm gonna do. So I have this piece of metal here. I cut into 2 little strips, and then I basically put this curve in it and drilled holes in it. And so what I'm gonna do is I'm gonna put it over top these guys, and that way it has some bounce in it. And then I'm gonna pull the wires through the bottom of here and then attach it to the ends of this. So let's get these drilled in and then we'll run the wires through. Now that we got the bottom all figured out, let's move on to making an enclosure for the inside, so that way they are waterproof. So I think that'll look a little something like, there we go. It's not the best looking, but she'll do. The next step is going to be to put the wires, attach the wires to this copper and run 2 lead wires out of here. And then we'll attach this to the post, and then we'll attach this to the post and see if we generate some power. I'm going to do this plate. I'm going to drill an inside hole and an outside hole and bring the wires up through and then solder them to this tape. That way it's directly connected, and we'll see how this works. I'm not too confident about it, but it's the best idea I had for right now, so. So I had the blades out there. They were made out of this stuff, and I thought it was a good idea at first because it had some flexibility, so I could rotate it like that and make the blades angled pretty easily. Well, because the blades are so long, even though they're the PVC, they're still pretty heavy, and this would, after a while, lose its curve, and basically it wouldn't catch air anymore because it didn't have that angle to it. So I tried to put the curve back in it, and I ended up breaking this piece. So this is like really chintzy. I mean, it's not aluminum, but it honestly feels like aluminum. Instead, I went to a hardware store and I just bought 2 pieces of rolled steel. They were $4.99 a piece for 3-foot sections. So now I'm going to do the same thing I did with those. I'll weld it together, drill a hole in here, and then put the same holes that I have, and then I'll put the twist in it, and then I'll put the blades on top of that. I got both the blades in the vise here, and what I want to do, from everything I've researched, is 35.5 roughly is the best degree angle to have from this. So what I want to do is take this and move it 35 degrees. So that's what I'm going to do now. I'm just taking my wrench, and this is anchored here. That's almost 45, so I basically want to put a preload in it. So even though this is probably at more of a 45, actually, now it's more of a 45. Since this is at 45, there's going to be preload, so the blades are basically going to want to come back a little bit. So I'm going to overbend it, and then hoping the blades come back. And then I'm going to do the same thing on the other side. And the reason I have them together is because the angle is going to want to be the same for every single blade across. So that end is going to be curved that way, where this end is going to be curved this way. So they're opposite. So that looks about a 45 to me. Now obviously this isn't perfect. If I really wanted to get it perfect, I get an angle finder on here, set it to 0, and then move it until it got to the exact angle. This is just going to be rough. That's good for now.
Okay, so the new blades are mounted now. So the next thing I need to put on here is a tail wing to catch the wind so that this is always pointing in the right direction. As you can see, the windmill does work, and on a day where there's basically no wind, it still turns, so that's a good sign. Today's not going to be one of those days that's going to produce a lot of electricity, but still, I mean, it still works. The new blade configuration is really nice. So even I stop it, let go, and that's with no wind. At this speed, I'm kind of curious how much power it's putting out. I bet it's not 12 volts like I want, but I mean, on a non-windy day like today, I'd like to see how much power it's putting out. So let's get the multimeter hooked up and see what we're looking at. It's blowing pretty fast. Well, as you saw out there, I wasn't getting any power to the wires at the bottom. So I took it apart and I kind of broke some connections. So if you look on here, that tape did not work. I mean, it just ripped right through it. Kind of went back to the drawing board and made this. What I did here is I just took some steel that I had lying around, cut it down, not very well as you can see. And then I'm gonna attach the lead wires back to the opposite end of the hole. And then I also, on here, I took these little metal pieces I had. They kind of just, yeah, that's kind of what ripped it up. And they weren't doing what I wanted. So I left the springs in there and I shortened them a little bit and widen the hole so that they can bounce a little bit better. I already test fitted it with this on here, and they do really well. They stay right on the tracks like they're supposed to. So I'm gonna reattach the lead wires on here, and then we'll go mount it back up and see if we can get power. So today's not a super windy day, and we're getting power from it. I think that's a success. I think that controller starts picking up power around 10 volts, so I mean, on a day that's pretty much dead in wind, this isn't bad. What it looks like on a windy day. Get a big gust here. Oh, here we go. Oh man. Jeez. Let's say it works. Last thing I'm going to build for this is a housing unit, hold the battery and hold the charge controller. I swear this is the last time I'm taking this off of here. So when I was up there, after I hooked everything up and was testing everything, I realized that these guys broke. I have a repair for them. I ordered these guys. They're actually the electrodes that come off of dog shock collars, but they're spring loaded. So I'm gonna put these on here and see if I can get these to work. I got these mounted to it. I went ahead and, because I didn't think I could be able to solder to these tabs, so I just went ahead and added some crimps to it. So all we gotta do is put these guys in here, crimp them down, slap it back on, we can take it outside. So while I was here fixing these guys, I also put a different one of these on. So this one, it's like, I'm not even gonna try. It's basically, I wouldn't say it's seized up, but it's a lot more difficult to move. Where this one, I mean, it's not like super easy, but it's still pretty easy. Like, there's not a lot of force there to make it slide. So I'm hoping, this was actually starting to work with this wing here. I made it out of that dishwasher. It started to work with that one. So I'm hoping with this one that turns a little bit easier, it'll catch the wind a lot better. It was doing a pretty good job, but it wouldn't turn. This whole box wouldn't turn until the wind was about 15 to 20 miles an hour. So I want it to be able to turn around, like, honestly 5, but ideally 10, because that's when it's generating the most power. But anyways, so since I got these little guys on here, and that part should be working pretty well, it actually sits out a little bit further than the bottom of this. So these should make contact perfectly with that ring that goes around the post. So let's go and get this back on there. Hopefully this is the last time and I can actually show you that it's making power and that the load is working correctly, and maybe hook a light bulb up or something like that. Last time, I hope. Oh my God. Oh my God, I did it. Look. Yeah, this is close. You see that? That means I'm generating power. Whew. Man, that is freaking awesome. And this tail, oh my God, with the new configuration, I mean, you can see it, you see it turning? So I judge like where the wind is blowing based off of that guy over there. So you can see that one turns a lot easier. That one turns a lot easier. But like this thing's almost perfectly with it. All right, let me button everything back up. So here's the inside of it. Man, it's really moving. I'm gonna drill a bunch of holes. Woo! Man, I'm just so excited that this works. All right, let me put the lid back on. So as you can see, everything works on it. It's doing pretty well. You can see this little guy here is showing that it's actually putting out power. So those little tongs that we have are actually working, catching on that disc. You can see I push the button and it turns the load on, allows it to take power out. Even on a non-windy day, this thing's catching wind pretty well. At first I was worried about being able to catch the wind, but with this new hinge on it, seems to work great. In the future, I want to upgrade some of the stuff. Like, this is not a super powerful charge controller, so I want to upgrade this. Possibly add more batteries, that way I can, power more things. So right now I don't have anything really hooked up to it. In the future, I have my bridge that I want to put lights on, and then I also want to put like a poured cement pad, pergola, gazebo type thing down by the creek, and I want it all to be powered off of this. So I'm going to need a lot more batteries, that way it can store the power. On a windy day like today, it should be able to generate all that power back. Stay tuned for some of that stuff. But yeah, I'm really happy with this, how it turned out. Bunch of setbacks, but nothing was too major that we couldn't figure out. I mean, most of the stuff was built out of scraps that I just had lying around. You can see all this wood is just, stuff I had lying around. I still have to go back and seal all these gaps so that no water gets in. Hope you guys enjoyed. If you have any questions, just hit me up in the comments. Until next time, I'm Lane from Maker's Lane. You guys have a good one.